So welcome everyone to hear about referential integrity. So let's get going. Who am I? For those of you who do not know, I am the FHIR Product Director, which means that whatever you don't like about FHIR, you can come and hassle me about. That's my official job. I have been a health interoperability consultant for a long time. And I started with FHIR about 10 years ago. You might have seen the video about that. All right, so we're going to talk about referential integrity because there's some interesting challenges associated with that. I'm going to start by talking about referential, what it is, what the specification says about it. I'm going to look at how you can maintain referential integrity and some practical challenges associated with that. So referential integrity from Wikipedia is a property of data such as all references are valid, or in a FHIR context or RESTful context, there's no broken links. I prefer to think of it as a property of a system such that it ensures that references are to data that actually exists. In practice, that means that if you have an observation like this that has a subject, which is patient/F001, then if you do a get on the base that you got that observation from, observation F001, if you do a get for patient/F001, you will get a patient back, 200 OK. You will not get a 404 not found. And that's what referential integrity effectively is at a FHIR level. Now, FHIR says very little about referential integrity. It says regarding update, servers are permitted to reject update interactions because of integrity concerns or other business rules. So it's not even like directly mentioned. And this sometimes generates questions to us because people are like, but referential integrity is really important. How can you not really mention it? We do get closer to mentioning it on delete. The server may refuse to delete a resource because of referential integrity. So you might say, well, I'm not going to release it, delete this resource because some other resource is pointing to it. Servers may choose to enforce business rules regarding deletion of resources that are being referenced by other resources, but they also may not do so. They may allow for the data to be deleted and break referential integrity. So from a client point of view, it's a bit unpredictable because servers may choose to do so or not. And it's pretty much all we directly say about referential integrity. We do sort of say something tangential about it in that we say on the page, the RESTful page, that both client and server systems should clearly document how transaction integrity is handled in the documentation in their capability statement. Implicit in that, but not explicit, is the idea that they should document referential integrity constraints because they are part of transaction integrity. We'll come back to that subject, but it's but FHIR says very little about referential integrity. So a lot of FHIR implementers come from the enterprise information system space, where enforcing referential integrity is natural and necessary. You just don't think about not enforcing referential integrity. The databases enforce it, and you take opportunities as you see them in high-level processes to enforce high levels of referential integrity. I'm going to say at this point, when I say referential integrity, for this talk, I'm really focusing very near field referential integrity. If you have a reference to a patient, does it exist? There's a different kind of integrity, which is if I have an observation that references a patient and it references an encounter, does the encounter reference the same patient? we're not talking about that kind of cascading referential integrity, and that's really, really tricky because in some clinical conditions the answer is no, but they're very rare. So that's kind of tricky, but I'm not talking about that. So enterprise information systems, primary sources of information, systems that support, integrated business workflows. Those are systems that logically and naturally enforce referential integrity. But there's all sorts of reasons why you might deal with systems or write systems or design systems that do not enforce referential integrity. And the first and most obvious cases are in security. The resource might exist. The reference maybe be there, but the client, for whatever reason, doesn't presently have access to the target of the reference. Now, in general, you probably shouldn't get into that situation where a resource that you have access to refers by ID to a resource you don't have access to. But it certainly happens. And so you can't get access to it. And so you don't know generally whether referential integrity is maintained or not. And in fact, in some systems, if you couldn't get access to it, but you knew the system was enforcing referential integrity, you would therefore know that it existed. And in some security concerns, that's a sort of frameworks, that's a problem. Now, the most common thing in practice is that secondary sinks of data, where you're absorbing data from other parts of the hospital or, the healthcare network, clinical data repositories of various kinds or others, they may get partial records. And I've talked to people implementing these in production, and they're like, we'll take any data we can get, anything. It doesn't matter how bad it is, we'll keep it and we'll store it, and maybe we can do something with it later. And so clinical data repositories very often get partial records, very often don't have access, or the information they want doesn't exist, or they won't get it in any business process that's viable. And so they just have to go, we get a bunch of broken links. We know what we know the performer of this observation, but we'll never know anything about the performer. All we have is a reference. So that's very common. And then often you have asynchronous processes where things arrive out of order. I worked this is a particular problem in V2 interfaces where you get a lab order interface, and the lab's getting order information from the clinical system, and it's getting patient information from the patient system. And there's some kind of delay in the patient system HL7 feed, the V2 feed. And so the consequence is the ordering system sends you the order on a patient that you haven't yet seen and heard about because the patient hasn't arrived. More and more as people integrate systems and do wide area network stuff and business process remediation, I see people bringing up architecture diagrams where they have complicated process flows running through many systems. And one of the things they have to deal with is that things may arrive out of order, which is informationally inconsistent, but only transiently, but totally screws up your data handling rules. And of course, legacy data, where the data you think that it points to, the pointer's there, but the data's gone. Well, what are you going to do about that? And, that's not that uncommon. Another cause is basically broken business processes, and not even necessarily broken. Paper business processes are very flexible in terms of error handling and error exit conditions. And it's really hard to automate those. And sometimes people are saying you have to automate what we have, and it's broken. And so you're just never going to get the information that you think you might get. Sometimes not going to get it consistently. And finally, audit archive trails, audit event, provenance, information about resources. You want to keep that long after resources are deleted, and I'll come back to that. So I'm going to talk a little bit about the kinds of references we have. So these are all the observation reference, and these are all valid references. So you might, I see I've got a mistake on this slide, oh dear. So you might say the most simple, obvious case is you're on a RESTful interface, you get an observation and it has a local reference to a patient, patient/1234. So that means that you're going to find a patient on the same server that you found the observation, just at patient/1234. And you know that it's a patient because it's a RESTful API to patient. Or you might find just a full URL like this, or some URL you don't recognize, some server, some path, somewhere. In theory, at least in a conformance system, if you access that URL, you'll get a patient resource if you ask for the right line type. But of course, it's not tremendously useful looking at that. And so the next reference is supposed to be some server, some path, not patient1234. And you might also know that it's a patient. So you know that it's a patient in advance. It doesn't really matter for referential integrity, but I was trying to be complete. Or you might have hashpat as a reference, which is an internal reference to a resource inside the observation that carries a patient. We don't like contained resources, which is what these are. They live inside the resource, but they are necessary evil sometimes. So let's leave that particular question aside. When it comes to referential integrity, the specification itself mandates that internal references of the hashpat form are always valid. They must be valid because they're self-contained, and effectively there's no excuse for being not able to find or access or see or convey information because inside the resource you're looking for. So when it comes to referential integrity, internal references to contained resources are required to be valid, but none of the others are required to be valid, not at the level of the specification. The server might choose to say, we want to make a reference patient1234 valid. That would imply then that if you're going to make patient references in subject references in observations mandatory, you probably won't accept a full URL as a reference to a subject because you're going to enforce referential integrity internally. It's really hard to enforce referential integrity on an external reference. You're going to stop it being deleted. You're going to stop the server disappearing, getting renamed. Typically, systems that enforce referential integrity do not allow external references. I mean, maybe you've got a combined server where you've got external references to another server you manage under your policy. So it's possible. Well, we didn't say it was not allowed, but it's pretty unusual. There's a second kind of reference, which is where you're referenced by identifier. So you say, hey, this subject on this observation, I don't actually know what you have it as. I don't know what patient it is for you, but I know that it's a patient with an identifier of 1234 in that namespace given there. Good luck finding that, but if you can find that, then that's who the patient is. So those are not popular references, but sometimes you need them because you don't know what the local reference is, but you do know what the identifier, shared identifier is. It's a bit of a problem if the identifier is not shared and not known. And as you see, you can also tell the system that it's a patient reference because you couldn't tell looking at the identifier. You have to find it. And in fact, in some systems, the way some identifiers are used, that could be ambiguous. In fact, which kind of subject are we talking about? We discourage use of identifiers like that, but we live in the real world. So in my general theory is that identifier-based references are much more likely to be broken references than direct URL references. And I think that most systems that were enforcing referential integrity would reject identifier-based references. You don't have to. That's more likely. So in terms of references to resources to look in, when you get a resource and you're processing it into your store, then, and you're going to look for broken references, you obviously have to look at any elements with a data type of reference that reference other resources. You also have to look at any data types that have canonical, that are references to canonical resources. You may decide that you want to enforce referential integrities on URIs and URLs and OIDs and UIDs. Wouldn't use them that much, but maybe you care, and URL in particular. And the other thing is that URLs can refer to resources directly, and URLs that refer to resources, particularly binaries, images, can be found inside Markdown and XHTML. You've got to hunt them down and check them, really, if you're going to be thorough. In fact, when I was preparing this talk, I realized that my server has long checked XHTML, but doesn't presently check referential integrity on Markdown. Good effort, me. So something for me to add to my to-do list on test.fhir.org when we're running in referential integrity mode, which, by the way, I never run test.fhir.org with referential integrity turned on. It just causes too much confusion for people who are just hacking on the API. But it does cause confusion downstream for people going, well, why doesn't test.fhir.org enforce referential integrity? It could. It just annoys people. So I want to talk about versioning and reference integrity. So this is kind of obscure unless you've actually implemented the server API, but FHIR is conceived as, is understood in your head as an insert-only database at the version level. Every resource consists of a set of commits to a database of versions of the resource at a given time. And some of those versions are just a deleted flag. So a deleted resource still exists and has a history. You just get a 404 when you access it because the current version is got the deleted flag on it. So version-specific references, if you refer using a version-specific reference to an existing version of the record, that reference isn't broken by deleting the record, because you're referring to a past version. The past version is never going to stop existing. Well, at least it's never going to be replaced. It may stop existing because you ran out of space and cleared out old versions, for instance. But at least they won't be replaced with something else. But that's if the system actually implements full version tracking. And the native FHIR servers like Happy and Vault, that's what they do. But if you're writing FHIR as a front end over an existing database system, by and large, those systems don't do version history. Some do, but most don't. But once you throw in version-specific references and trying to figure out whether you've got a current or a past reference, it's really complicated. And I haven't seen anybody actually make this work. I haven't seen anyone actually make version-specific references work in a working system. I've seen document specifications that require version-specific references in the documents. It's kind of funny because you can get away with it because it doesn't matter because you're in a document. It's kind of self-limiting. And the whole question of versioning and referential integrity is just a permutation explosion of complexity. Just insane. If anybody thinks they've nailed that, tell us all about it on Julep, man, because it's hard stuff. All right. So let's talk about how to actually maintain referential integrity. Let's start by saying we are going to, the client posts an observation to with the subject that refers to a patient you don't have on the system, and your rule is referential integrity is enforced. And so this is the actual response that comes back from the server when the server says, I don't know that patient. You get an operation outcome with a severity of error because the post didn't happen, the code is not found. The subject was not known, and the subject observation dot subject dot reference was not known. That's how the server returns a failure when it's maintaining referential integrity. That assumes that when the observation is submitted to the server looks at the observation, sees the subject, checks the reference, can't find the reference, and then returns this error. All servers will look at the subject reference and do something with it because they have to index it, or they have to remember that it exists so they can enforce referential integrity on the target of the reference, because you can't delete that. So let's talk about that. Oh no, I was going to talk about this first before I went on to talk about deletion. Okay, so if you're posting a resource, basically you need to go and look at all the dependencies and make sure they already exist on the server. And then for each of them, figure out what their ID is on the server. Maybe you need to do a create on the server. And then you get back to the resource you were going to commit. And what do you do if the commits failed before you got to the resource you were going to commit? Do you need to undo them? All complicated stuff. In practice, when you start thinking like this, use a transaction. And basically, a transaction is a little bundle where you've bundled up everything that the server might need if it doesn't already have, do them as conditional creates, hand it all over to the server and say it all fails or passes as a single effort. So there's a price to pay for making it the server's problem, which is there's a very definite complexity around transactions. But it's particularly when you get into referential integrity, you've got the complexity one way or another anyway. And so that's when it's really worth looking at transactions and making it the server's problem. Of course, that means you need a server that supports transactions. Hard work for a server to support transactions. So a lot of them don't, or they support them in a very limited way. You have to ask the server and see whether that's possible. The general purpose servers generally implement transactions very thoroughly. Much harder if you're doing a facade on an existing server. So the other thing around referential integrity is you've got an observation that points to patient 1234, and someone says, I want to delete patient 1234, and they'll get back a 422 business rule violation that says an operation outcome, a business rule, other records refer to this patient, and the path not incredibly useful patient. And of course, both of those operation outcomes are stripped to text to make the slides readable, but they'd have some human readable text explaining what the problem was. You can't delete the patient because there's still records stored against the patient. Of course, that's a business rule the server decides to buy into or not. So when it comes to maintaining referential integrity, my view is that almost every server should enforce some referential integrity. So clear exception is the test servers online, test.file.org. I don't bother with referential integrity for them. But for any real clinical system, you're going to have some referential integrity, nuts to have none. But the exact rules depend on context. For instance, it's pretty standard to keep audit events and provenance trails around resources that have been deleted. It's the point. You have an audit trail to say this was deleted. You can't delete the audit trail when you delete something. So you don't want integrity on those. Another really common business workflow is to get a diagnostic report with a stated order. It's based on an order, but you don't know that. You don't know anything about that order. It's very common in clinical practice. And so you don't want a server that requires data integrity on diagnostic report based on. On the other hand, you probably really, in a clinical system that really is meaningful, You really don't want to have a resource where the subject points to something you don't know what it means. Why do you have the data? It's pointless and useless to you. So pretty much, unless you're one of those general purpose clinical data repositories that takes everything and hopes for the best later, you pretty much should have integrity on subject. It'd be like having a medication. Another case would be a medication administration that refers to a medication. You don't know anything about the medication administration unless you have a medication. So you really should enforce integrity on something like that. But so it's actually contextual as to whether you should have referential integrity. Now, one particular issue is around histories. So when you get a history off the server, you subscribe to the server and get a history from the server. The history explicitly is documented that the transaction boundaries may not be represented and a resource may come more than once. And so, for instance, that might mean that the server was committing a set of resources as a transaction and it did so. But when you get a history, you get half of them. When you do the next history, you get the next half of them. And you don't know where the transaction boundary was. Now, that's specific to FHIR history bundles, but it's a general issue with subscribing or replicating or secondary feeds from a primary database, which is that almost always those can be out of order. It's a version of the asynchronous problem. Those can arrive out of order, and so the secondary feed has to say, well, I'm getting whatever the server enforced. I just have to suck it up and get what the server enforces. So secondary servers almost always can't enforce referential integrity. One particular tricky issue is circular references. And the most common circular reference is patient links. So here we have two patient records that are known to refer to the same patient. And for some reason, the institution hasn't merged the patient records. The whole subject of patient merge, I think, horribly complicated subject. I spoke about that 2 DevDays ago, and that is still, that presentation's online if you want to look up FHIR and patient merge and DevDays. But it's particularly tricky because in this case, the correct alignment is that patient A refers to patient B and patient B refers to patient A. And integrity is that both of those things happen. But you can't create, typically you would create B and then create A, and then find that they were the same and cross-link them. But if you're actually creating that record on a different server, already cross-linked, now you need to commit A that points to B, and then commit B so that it can point to A. Yes, so you can see that's potentially tricky. Transaction is obviously the answer. But I just wanted to point that out, that you will, in a real clinical system, it's very conceivable that you would run into that. This is not an edge case. Now, on Happy, Happy has an interceptor for control. And so that means a piece of software that runs inside the server that can allow you to control referential integrity. And so in particular, you can look at a resource that's been deleted and say, hey, I don't care about this deletion if the resource is referenced from an audit event or a provenance. It's fine. Just go ahead and do the deletion and keep those. Whereas you can say if it's referred to from any other place, then don't let the deletion happen. I was talking to, I mentioned Happy because I commit to Happy. So it's just kind of like first in my head. Other servers, same issue. There's nothing special about Happy. I don't know what the arrangements are, but they basically need an arrangement where you can, at a delete, you can say, which references do I care about and which do I not? Happy doesn't have, and it needs, and so I'll talk to James about getting an interceptor that allows you to say, hey, diagnostic report based on, I don't care. I'm not enforcing referential integrity on that. But observation of the subject, yep, I'm enforcing referential integrity on that. Happy, like my server, my other server, I have 2, Happy lets you turn referential integrity on globally for all resources or no resources, all references or no references, and it lets you turn them on selectively, and then you have to write software that sits inside the system enforcing that. All right, so where are we? Oh, I realize I've missed an issue, so let's get back to here. So when you, let's talk this slide. Sorry about this. So we see a reference like this, an incoming observation, and we say, well, that's interesting. I get an observation, but I don't know the patient. So what am I going to do about that incoming observation that doesn't have a patient? There's really a number of choices I can make. The first choice is I can say, well, I'm not accepting that observation and return an error, a 422 like I showed. And this is more talking about the kind of decisions you'd make on the client and the server. So the client is a external business process integration client, where it can say, you know, I haven't got that patient. I'm going to sit on the observation for 24 hours to see if the patient record turns up. And as soon as I see that the patient record's created, then I'm going to put the observation against it. You could do that. Another server system I worked with, they deleted the patient subject reference. They just looked at patient 1234 and said, well, it's not valid, so we'll delete it. I'm like, really? Why did you even bother with referential integrity? It's to make the system safe. I'm like, so you responded to that by just deleting the information in the first place. Well, it seemed like a circular logic own goal to me, but that's what they did. Another system that I had every resource had a 0. So they had referential integrity enforced, but every resource there was a 0. So patient/0, and the 0 resource meant, well, it's not a valid resource. So then you would have patient 1234, and you'd replace that with patient 0 to show that it was invalid, but you still had referential integrity. Like, really? It's about the same. Why did you bother doing that? You lost information, you have integrity, but you have a meaningless process. At least as far as I can tell, that's how it works. But those are your choices. So that's, you know, that's pretty meh. All right, sorry about that. I forgot to talk about that back then. Okay, so what have we learned? It's up to the server to enforce how much referential integrity it wants. My general contention is that almost all servers need some, and almost no servers need everything. But what we need is that clients and servers need to document their expectations. I have never seen this done. I'm sure that none of you have done so. And so I'm sure we're all operating in a fog of darkness, hoping for the best, and it probably works most of the time. The API allows servers to enforce integrity. They are absolutely allowed to do so, but creating clear error messages is always a useful thing to do. These are the kind of errors that crop up in user experience rather than developer testing. And the corner cases are extremely messy. All right. During DevDays, you can find me here, yes. All right, questions and answers, and I see 2 questions in the Q&A. So let's start with them. Are there ways to mandate referential integrity via profiling? No, there's not. Well, in fact, there is with FHIR, but it's a pretty blunt tool. So first of all, in general, profiling doesn't let you say anything about targets of references. You can't say whether they have to exist or not. You can let's have a look here. You can, yes. There is a resource called graph definition, which talks about the relationship between resources across the links. You could, with the graph definition, require certain links be fulfilled on the system. But not a lot of people have worked with graph definition. It does a lot of other things. Not a happy place to start that discussion. Maybe if people really want to talk about that, we can talk about that on Julep. But in the classic resource on structure definition, then no, you can't say anything about resource. On the other hand, there is a constraint in release 4. I think I fixed it in the technical correction though, so I can't find it quickly, that accidentally, so let's do this. Here's my constraint that I'm going to make. I'm going to make it on observation. Yes, there we go. So let's make this bigger. I just wrote this FHIR pass constraint on my profile for observation, which says that your subject must resolve and it must exist. Whatever gets back must exist. There you go. I wrote a profile that mandates referential integrity, but it doesn't work because the validator doesn't know what to do with this. The validator will always fail because it doesn't have access to the API. Long story, making this work. It's research. So the theory is yes, but the practice is no. Subject not found. All right, back to my slides. I think it was this, subject not found. What happened if the observation is to an external reference to patient? Well, that's up to the server. The server can say, okay, well, you referred to a patient over on some other server. I'll go and check and see if I know it. And if I don't, then I won't. If I get back a 404, then I'll reject your post. But in practice, I've never seen that. I've only ever seen referential integrity enforced on systems that only accept local references because they can steward and curate the referential integrity rule going forwards. But you might decide to do otherwise. It's up to you. We don't say anything about that. What about a referential integrity in a federated solution where a lot of databases could be remote? Indeed, yes, that's what I was just talking about. You can have a federated solution and you can tie yourself up in knots. And we all love federated solutions because they tie all the developers up in knots. Well, we can do it. Well, I wouldn't recommend that you do, but often we end up doing things that we didn't recommend to do because we were told that we had to do them. So I really not sure what else we could say about that. Would you moderate your advice on reinforcing referential integrity using identifiers in the case of national patient identifiers? Well, I don't know whether I would moderate my advice. I guess that was a reference to, let's see, this slide where I said you generally would not enforce referential integrity on a reference identifier. Well, no, you generally wouldn't. Maybe that's a case where you would if you had a national patient identifier. Maybe. Given that servers will assign their own ID to a resource, do you recommend moving the incoming ID to the identifier array so that integrity can be handled for future data? You know, that's a very deep and meaningful question. I actually spoke about that at the last DevDays. search for a DevDays talk about combining data from multiple servers, where I consider that question in detail. My quick advice is no. An ID that exists, a technical ID, should not be elevated to a business ID. But sometimes you have no choice. But you should always try and avoid that, because otherwise your resources will end up scattered with technical IDs that look like business IDs but have no meaning outside a very limited context. So I would always encourage you not to do that. But of course you can do that. I think that was, I wasn't marking them as answered on my. So any more questions? Well, indeed, we have 3 minutes. Okay. All right. Well, thank you, everybody. I hope that was useful. You can do a review, and I will hand back to, let me get down the end of my slides. I'll hand back to, well, is it Eric, I guess?
All right. Thank you, Grahame. All right. Thanks, everyone. That does it for today, this session. Recordings will be posted later today. Thank you.